Welcome to a demonstration of SpaceClaim for analysis. Today we'll be looking at importing different models, repairing geometry on import and preparing models for analysis, as well as communicating changes back to the rest of the team. The housing that we see on screen is still being worked out by engineering. To make sure that we reach a final design quicker, we've decided to do some analysis so we can give input early on in the design cycle. Engineering has added some additional components to the design, so we'll need to bring in a new ECAD file, which will provide more power, but also give off more heat. In addition to replacing some parts, we can bring in additional components as well. These were provided for us in the IGES format. We can see that these files look slightly different from the other parts we'll be using. Let's open these in their own window so we can get a better look at them. Sometimes files don't come in correctly, and I can see that two of these are surfaces. In SpaceClaim, we have tools to both repair and prepare geometry for analysis. We can get rid of any gaps in the model, get rid of small faces, which could bog down our mesh, or even get rid of rounds that might be there, removing them from one part or as many as we wish. Now that we've repaired some of the geometry we've imported, let's look at setting this up for an analysis. What we really need is the space around all of our components and the inside of the housing. For this, we can create the volume on the inside of our part. We'll just mark off all of the flow exits and create our inner volume. It's a little bit easier to see if we open this up and take a look. Here we can see how the solid representing the flow contains all of the necessary surfaces. Sometimes though, if we go back to our original assembly, it's easier to see when we drop down into a cross-section. Once we create the volume though, we might want to make some changes. If we find that the housing gets too hot from our circuit board, we might want to move it to a larger area inside. We can move the board to the back and see the space it used to occupy, and we can make all of these changes while we're in a 2D section. Then if we need to make a new volume, we can recreate the old one simply by clicking it. Now we have a new volume that we can analyze and see the results. If it's still too hot inside the housing, another solution we might recommend is that slots be added to the top of the housing. In SpaceClaim, we can create geometry both in 3D and in a 2D environment. We can quickly create a solid and pattern it over to create as many slots as we need. We can create geometry in SpaceClaim and use it to tweak parts that we bring in. After making the slots, we'll use them to cut away the housing, producing vents in the top. Now we could run the analysis again and see if this helps. As an analyst, if I make any changes to the model, I need to document them so I can communicate them back to the rest of the team, and they can be incorporated into the master CAD model. For that, I can use SpaceClaim's 3D markup. 3D markup allows me to compare different versions of a model while I'm working with them. Here we can see the old model and the new one, which I've added vents to. In 3D markup, you can document it further by adding any notes or dimensions that you might need. Here we're indicating that it was necessary to put vents on top of the housing to appropriately cool it. Or showing color change face mode, which will highlight which faces were changed by what color they are. SpaceClaim Engineer can help you pre-process and make changes for analysis, bringing the power back into the analyst's hands.